Hello guys, good afternoon all of you. We have completed AC voltage regulator of R load, and I will encourage you guys to please uh, do RL load by yourself because it is similar, and whatever will the problem you will face, I will clear it. Okay, I want you guys to at least try, give a try. Okay, so now today we will start a new topic called TRAIC. Okay, what exactly is TRAIC? We will understand. Okay, so what we will understand today, our outline will be meaning of TRAIC. What is the meaning of TRAIC? Use of TRAIC, symbol of TRAIC, TRAIC equivalent circuit we will see, and the characteristics of TRAIC and application of TRAIC. Okay, so now we will start with the meaning of TRAIC. So first of all, I wanted to tell you guys what TRAIC is exactly. As we have seen, an SCR is a unidirectional device. We discussed SCR, thyristor and all these things in our chapter 1, unit 1. So we know what is SCR and how it is unidirectional device. It can be conducted from anode to cathode. We know all these things. Okay, and not from cathode to anode, only from anode to cathode. But here TRAIC can however conduct in both the directions. A TRAIC is thus a bidirectional thyristor because TRAIC can conduct in both the direction. Okay, from anode to cathode or from cathode to anode also. Okay, so it is bidirectional thyristor with three terminals. We will see how it is three terminals, and it is used extensively for control of power. Okay, we will see the that's use also. We will see the use also, use of TRAIC. So now we will start meaning of TRAIC. What, how it become TRAIC? So triode TRAIC is made from the word triode for alternating current. So triode, we will take tri, and from alternating current we will take A and C. It becomes TRAIC. So however it is a combination of capital letters from the word triode and AC. Okay, so it is a bidirectional three terminal device. It is a advanced version of diode, you can say. Also it is a advanced version of diode. Now use of TRAIC, where we use TRAIC. So unlike SCR, TRAIC can trigger in both the direction. As I discussed already, it is a bidirectional. Okay, we can be conduct, we can conduct from anode to cathode and cathode to anode. So it is a bidirectional device. So unlike SCR, TRAIC can trigger in both the direction. We can use where we need this kind of where we need both the direction. We need to trigger our device in both the direction, so we can use their TRAIC. So it is basically used for power control. It is basically used for power control. So now you can see symbol of TRAIC. So symbol of TRAIC is they see you can see the two SCR are connected anti-parallel. Okay, two SCR are connected anti-parallel with a gate signal. Okay, so here you can say equivalent to two SCR connected anti-parallel. The circuit symbol and its characteristics are we will see later. Okay, so it is only the symbol of TRAIC. So now we will see TRAIC equivalent circuit. You can also make like this NPN. Okay, TRAIC equivalent circuit. You can we can here it is first terminal is MT1, second terminal is MT2, and third terminal is gate signal, where we will provide gate signal. Here we will control our TRAIC from gate signal. So you can see that two SCR are connected, thyristor are connected with anti-parallel. Okay, two thyristor are connected anti-parallel. Okay, so we can see, we can connect like that. The physical analogy, you can say like that. If you wanted to see the two thyristor analogy, so how it is connected exactly in a practical scenario. So here is your thyristor 1 T1, and here is your thyristor 2 T2, and uh, we take both the gate signal, and we make it one. We combine the gate signal, and we are controlling from that gate signal both the thyristor. This is your MT1, this is your MT2. Okay, TRAIC equivalent circuit, you can see it. And you can also make, if you wanted to elaborate your equivalent circuit, so how you can see that this is P N P N, this is P N P N, and this is there you have N P N P. Okay, okay, now you connected these both and called it MT1. You connected this both and called it MT2. Okay, and you shorted the both the gate, and you called it gate, common gate. Okay, this is common gate of both PN and NPN. Okay, so this is how you can also understand the equivalent circuit of a track. This is how it is connected. Okay, and one more thing I wanted to tell you guys, that we know that a track is four layer. How it is four layer? PN. Okay, this is how you can understand it is a four layer. PN, it is positive direction, and the NP is negative direction. Okay, this is used for positive direction, and this is used for negative direction. Three terminals, how? This is one terminal, this is your MT2 second terminal, and this is third. So it is three terminal. So if somebody will ask what is TRAIC, so TRAIC is a four layer four layer PN, and PN is used for positive direction, and NPNP is used for negative direction. In the negative direction, and three terminal MT1, MT2, and gate three terminal bidirectional device that blocks current in its off state, acting like an open circuit switch. But unlike a conventional thyristor, the TRAIC can conduct current in either direction when triggered by a single state pulse. So this is how you can explain what is TRAIC. So I have given you a PDF. Okay, go through that PDF. All the information what you have to write, what I have just explained, all the things are there. So we are just explaining the concept. Okay, we will not write anything here. Okay, it will waste of time. That already written in your books, in my handouts, in my PDF. So no need to again write and waste time. So I'm just here to explain things how it works. Now come to the main point, characteristics, or VI characteristics you can call. Okay, VI characteristics. Here it is your V. Okay, positive V, here is positive I, here your negative I, and here your negative V. Okay, now how you will explain this? How you will explain this operation? So this is your gate signal. When you are providing this gate signal to control your TRAIC. Okay, here in this quadrant, MT1 is positive with respect to MT2. MT1 is positive with respect to MT2, and in this quadrant, MT2 is positive with respect to MT1. Okay, when we give when a TRAIC is on, okay, we give gate signal. So here is the gate signal, gate 1, gate 2, IG1, IG2, IG3. Here you can see and Ig3 is greater than Ig2 and Ig2 is greater than Ig1. That means Ig1 is smaller. Okay, so here we observe that Ig1, when the gate signal is increasing, when we are increasing the gate signal, your voltage is decreasing. See, Ig1 your voltage is like here, for Ig2 your voltage is here. So it is, whenever we are increasing gate signal, the increasing gate signal, but here our voltage is decreasing. So what we got, if we increase gate signal, voltage will decrease, and here it breakdowns. Okay, breakdown start and your TRAIC start to conduct. We know what is latching, holding current, all these concepts we know, we have discussed already in unit 1. So again here we will discuss, we will not discuss all these things. What is latching current, what is holding current, on all these things. Okay, so we all know all these things. Just how it works, we are increasing gate signal, and here at this point your TRAIC will start conducting. We will explain later how it, what is the breakover voltage, what is all these things. Just understand the characteristic. Okay, this is your positive breakover voltage. Okay, here you are. Okay, we will see later. Okay, now in the reverse direction you can see the gate signal. See, we give gates Ig1, Ig2 and Ig3. Again here the Ig3 is greater than Ig2 and Ig2 is greater than Ig1. Here also your Ig1 is here and Ig2 is here and Ig3 is here. So you can see, because it is negative voltage, so your Ig1 is, when you are increasing the actually you are decreasing the voltage. Okay, you are decreasing the gate signal. Okay, you are decreasing the, you can see because it is negative aspect, negative coordinate na? So we have to understand the Ig3 we are increasing. Okay, increasing, now your voltage is decreasing, same like that, because here your voltage will be high, here your voltage will be low, because you are working on negative scale. Okay, negative scale. So for Ig3 your voltage will be more, for Ig2 your voltage will be less, for Ig1 it is more or less. So when you are increasing your gate signal, when you will increasing your gate signal, same concept as this. For Ig1 the gate voltage is more, for Ig2 gate voltage is less, for Ig1 gate voltage is less, for Ig2 it is more than Ig1, for Ig3 it is higher, the voltage will be higher. Okay, now applications where we use TRAIC. So TRAIC we use for lamps control. Okay, for lamp control, speed control of fan. So it works in both the directions, it is bi-directional device, so we can use it to control the speed of fan. It is used in chopper also, it is used in AC phase control. Okay, so now what we have to study is modes of operation of TRAIC. So what are the modes of operation of TRAIC? So here we can see we have one terminal called MT2, here N4, P1, N1 and N1, P2, N2, N3. So we will start what is how modes of operation of TRAIC is work. So MT2, sorry, I have changed the, it should be N2, N3. Maybe I made a mistake. Okay, it is N2, N3 and it is N2, N3, all are same. So P1, N1, P2, N2, N3, N4. So how we will understand mode of operation. See, first mode will be when MT2 is positive. So MT2 is positive. Okay, and gate is positive. So gate is positive, that means this is K, gate signal. You can call G also. Okay, gate is positive, so we will connect battery here and made it positive. That means definitely empty one is negative, then only circuit will be. Okay, now what happened? The current will flow, the current will flow like this IG gate current will flow from negative to positive. Okay, and when current will flow like this, the charge carrier will inject the charge carrier will inject from P2 to N2, P2 to N2. Okay, P2 to N2. Understand? When we will make this gate terminal positive and this empty negative and this M2 positive, so what happened? The current will flow from negative to positive like this, and the charge carrier will inject from P2 to N2, and because it is like that and it is positive, so this junction, which is P1N1 junction, this junction will become forward bias. Okay, understand? And this junction, which is N1 P2, will become reverse bias, okay, and the current will flow. How it flow? Current, the current will flow from M1 MT2 to P1 N1 P2 and N2, like this it will flow. Okay, the current will flow MT2 from MT2 terminal to P1 N1 P2 N2. So the current will flow P1 N1 N2, sorry, here N2. Okay, this is your how your current will flow when the MT2 is positive and gate is positive. This is your first mode of operation. Now we will see what is the second mode of operation. Okay, now what happened when MT2 is positive and gate is negative? So what we will do here now, we will connect gate to negative and from MT1 to positive, but MT2 is positive, the MT2 is positive only. The MT2 is positive, gate is negative. Now the current will flow from negative to positive like that. The IG will be in this direction, IG will be in this direction, and if IG will be in this direction, the charge carrier will inject from PT to N3 in this direction. Okay, the charge carrier will inject from PT to N3, and after that what will happen? Same, because it is positive, so P1 N1, this junction will again become forward bias, and N1 P2 will again become reverse bias. So how the current will flow? The current will flow from P1 from N1 to P2 to N3, from P1 N1 P2 to, sorry, it is N3. So current will flow like this. Understand? This is your second mode of operation when MT2 is positive, gate is negative. Okay, now will come third mode of operation. Here we can see what we will do when MT2 is negative, this terminal become negative. So when this terminal will become negative, what will happen? And gate is negative, so first we will connect gate is negative and this MT1 terminal is positive, so current automatically will flow IG1, and charge carrier, sorry, will inject from PT to N3, okay, in this direction. But what will change? Because MT2 is negative, what will happen? This PN junction will become reverse bias, okay, until it is forward bias, because it was positive, now it will become reverse bias. Okay, we know how things become reverse bias and forward bias. So, and this junction N1 P2 will become forward bias. This become forward bias. Okay, so how the current will flow? Here we can see the current will flow from like that, from P2, from N2, from P2 N1, P1, and one thing more, it is reverse bias, but P1 N4 junction is forward bias. So it will go like this. Okay, so it will flow like that, P2 N1, P2 N1, P1 N4. It will flow like that. For fourth mode of operation, we can say that the MT2 is negative. MT2 is negative. Sorry, MT2 is negative. Okay, and gate is positive. Now here gate is positive, and this MT1 is negative. Okay, so current will be flow like this, IG. Okay, IG will flow like this. So IG will flow like this. So charge carrier will inject from PT to N2. Okay, charge carrier inject from P2 N2, and because it is MT2 is negative, so again this junction will become reverse bias, and this junction will become forward bias, and the current will flow like this from P2 to N2, and P1 and N4 junction will become forward bias. So it will flow like this. So it will flow same as third mode of operation, P2 to N1, P1, N4. Fine. We have understood how modes of operation of TRAIC work. First mode, when MT2 is positive and gate is positive. MT2 second, MT2 terminal is positive, gate is negative. And third mode of operation, when MT2 is negative and gate is also negative. And fourth will be MT2 is negative and gate is positive. Okay. Now what happened? This mode of operation will work for first quadrant. Okay, will work for first quadrant. This will work for second quadrant. This will work for third, and this will work for fourth quadrant. Now what is in the VI characteristic? We will understand how this modes of operation work. Okay, we know the characteristics of TRAIC will be like this. So when it is our this shaded portion is off state. Here the TRAIC is off. TRAIC is on off state. It's not on. Okay, off state forward voltage blocking. It is a forward voltage blocking mode. It is in your TRAIC is in forward voltage blocking mode. Okay, and this junction is your NP2 junction. This junction is your N1P2 junction. That means this junction. Okay, this is your forward breakdown in a forward bias junction. Okay, so now we will give what? Gate signal. We will start giving gate signal here, and at this point it will be on state. Your TRAIC will become conducting, start conducting. So this is your on state. Okay, this is your on state. That is your TRAIC are now start conducting. Okay, so how it work? This is your forward blocking voltage. You give a little bit more voltage, gate signal, and at this point of time your TRAIC start conducting. So this state will call on state, and this junction, this point is what? When N1P2 is N1P2, this junction, this is reverse bias junction. and here same as reverse bias. So this is your this is for first quadrant. This is your first quadrant, so this mode of operation will be used here. Okay, this is your first quadrant, this when MT2 is positive and gate is positive. Okay, and I will tell why we very rarely use second quadrant and fourth quadrant. It is we can use, but we are very rarely we use these quadrants, because most of the time practically we use first and third quadrant only. Okay, but we can use second and third quadrant. We will also, I will discuss only two quadrant, which is first quadrant and third quadrant. So fine, same this voltage which I shade, okay, it is off state, because it is off state reverse voltage blocking. Here your forward voltage blocking, because your voltage will be forward voltage, here your voltage is reverse voltage. Okay, so reverse voltage blocking, it is your reverse voltage blocking, and this junction is N1 P1 junction. Where is your N1 P1 junction? There is your N1 P1 junction, this junction, when the your diode TRAIC is in reverse bias. So this is your N1 P1 junction. So at this point, this is your N1 P1 breakdown. This is your N1 P1 breakdown. Here your breakdown will occur. Here your N1 P2 breakdown. This is N1 P2 breakdown. N1 P2 breakdown. So here your breakdown of a TRAIC will occur. Okay, and this is your third mode of operation. This is third mode of operation, and you will provide gate signal, and at this point of gate signal your TRAIC will be start conducting. So this is called on state conducting mode. Okay, this is your forward current scale, this is your reverse current scale. So I hope you understand modes of operation and how TRAIC concept of TRAIC. We will discuss all these things in our WhatsApp group. Thank you very much.